I wanted to say that we live in this amazing time, that for the first time in human history, we actually have the means, the technological means, part of them developed here at the museum too, to figure out whether we're alone in the universe. And I know there's a lot of things that are going wrong in our times, and a lot of things that are going through the news that you're not proud of, that I'm not proud of, but this is something that to me is astonishing, that our generation could be, we're building these telescopes right now, and I show you what we found so far, that generation that figures out, if when you look up in the sky, that there are other planets like ours with signs of life out there. And I think that, to me, is one of the most fascinating questions humankind has asked for thousands of years. Are we alone? So what I want to do today is I would like to change your view of our sky. And I'm a little bit cheeky. I'm saying 4.6 billion years of solitude. It could be more. We haven't found life on other planets yet. But, as I said, we have the means and we are building the telescopes to actually be able to spot signs of life on other worlds, planets orbiting alien suns right now. And here, this is just my graphical expertise. This is the Earth in different colors. So this is not images we get from anywhere. If you ever see an exoplanet image, an image of a planet around another star, we have no idea what its surface looked like. We have no idea if there's any planes. We have not much idea if there's any colors, okay? Artist impression. So a lot of the things that I'll show you is our imagination leading us on to discover these worlds and glimpse into what they're made out of. But so, are we alone in the universe? The sky is really our new horizon because we discovered other continents, we discovered other worlds, but now our next horizon is actually the sky out there. And when you go out at night, and I know it's a little hard to do in New York City, but when you go out at night, and in New York, I think somebody say you can spot 2 stars if you're lucky. There are thousands of stars that you would see in a nice dark place like Ithaca, New York. Having said that, there's not much else happening. It's very pretty. But we do see the sky, you know, that's like, it's a trade-off right there. And so when you go out in a darker place, just go and do 1, 2, 3, 4, 5. Science has told us, we have found, that 1 out of 5 alien suns, those stars that you see up there are other suns. Our sun is a star. 1 out of 5 of these alien suns that you see in the night sky actually have a planet that could potentially be like ours. What that means is that it's at the right distance where it's not too hot and not too cold, so you could have liquid water on the surface, and we could pick up signs of life if they exist just by looking at the light from that planet, and that the planet is small enough that it's a rock like the Earth. And so if you had a huge cosmic bathtub, you throw the Earth in, it would actually sink. You throw Saturn in, Saturn would actually swim. Because the mean density of Saturn, a gas giant, a very different kind of planet than the Earth, is less than water, while the mean density of the Earth is actually more than water, so you'd sink. So our view at the night sky is our view to other alien suns, and even so we can't spot them yet, it's also our view to unseen other worlds where somebody could ask themselves a similar question. Are we alone in this universe? Let me just give you a bit of an overview how we fit in this universe. This is an image of our galaxy. You are here, this is where we are. About halfway out from the center where there's a big black hole. And The whole galaxy is about 100,000 light years across. What that means is that light needs 100,000 years to get from this side to this side. It's like when you're driving a car, it's 4.5 hours to get to Ithaca. So if you don't have any cell phone reception, when you get to Ithaca, the message that you have, the news that you have, is 4.5 hours old, right? And so all these, sorry. Okay. So then all of these stars that you see out in the night sky, what they also are, that are our view back in time. Our closest star is 4 light years away. So we see it today like it was 4 years ago. And anybody who wants a nice birthday present, let's say somebody turns 20, Google a star 20 light years away, find it, bring your friend and say, I give you this star, the light that is arriving right now was sent out when you were born. Works every year, it's a beautiful present, really only costs internet access, that's mostly free. You do learn stuff in grad school. So, one of the things that I wanted to point out, all of these thousands of other worlds that we already have discovered, and we are above 3,000 now, are actually in this tiny region around our sun, in about 1,000 light years, so in our solar neighborhood. And as I said before, in our solar system, we were used to these planets. The inner ones are rocky because it's very hot, close to the sun. So gas and ice evaporated, only left rocky material here. And the outer ones have much more gas and ice. As I said, a cosmic bathtub. Jupiter or Saturn would swim, the Earth would sink. This is a size comparison. This is our Earth, and this is Jupiter, the gas giant. And yes, our Earth fits into the storm that is the red spot on Jupiter's surface. But how have we found these thousands of planets we found so far? Well, actually, we don't find the planets per se, but the star gives away that the planet exists. And so think about it this way, you go through Central Park, and you see somebody walking like this, right? And this is the person who doesn't want to go the direction the dog wants to go, right? You don't have to see the dog to know that somebody is actually pulling this person. And the further they go back, the bigger the dog. In a way, it's the same for stars. A planet pulls, the star leans back. They're really going around the center of mass, but it's an analogy. The star leans back. And so even though I don't see the planet here, I see that the star goes this direction when the planet is behind. And now this is not working. This direction when the planet is here. So by the wobble of the star, I can actually tell that somebody is tugging on it, something is tugging on it, and it's not a dog in this case, it's actually a planet. And that's what you see here. And so sometimes the viewing geometry is right, so that when this tugging occurs or this planet goes in front of the star, it actually blocks part of the stellar surface, of the hot stellar surface that makes the star bright, from our view. And so the star, for a little amount of time, a couple of hours, appears a little bit darker than it used to be. And that tells you that something blocks its surface light from your view, and that something, if it's small enough, is a planet. So it's bright, 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 then it's less bright because we don't see all the hot surface. And then when the planet goes out of our point of view, we see the full brightness of the star again. And that's what's called the transit method. This is what Kepler used to find thousands of planets out there in the sky. And if you look very closely at this animation, and this is an animation again, you see that when the planet's in front of the star, part of the light from the star gets filtered through the atmosphere of the planet, allowing us to read the chemical composition of the air of this other planet just by looking at the light that we get. And if you draw how many planets we've actually found, it's about 3,600 in current count. I think it's 3,691, but who can keep up? Luckily. I usually tell my grad students, don't worry, there's more than one planet for everyone. And then we have a lot of signals that we still look at. But basically, if this is the size of the planet, 11 is the size of Jupiter, and 1 is the size of the Earth, then this is how many there are. So we have many, many, many more of the small planets than of the big planets. What's really exciting for me, because I like the small planets, because I would like to find life in our lifetime. And I said most of these stars we see indirectly by the movement of their stars. Most of these planets we actually don't see directly. But we already have a handful of these planets, and there's a brown dwarf just over there on this image, where the planet is far enough away from the star, or we can block out the stellar light with a mask, so we can see this dot of a planet. And of course, to me personally, the ones that are most interesting are the ones that are in this temperate zone, where it's not too hot and not too cold for there to be liquid water on the surface. So liquid water is one of the key ingredients for life, and it also allows us to actually see the gases that life breathes in and out in the air. If you have a huge layer of ice, and Enceladus was the example we had before, this icy moon, you actually have to go, drill a hole, and see if there's a fish. Could be a fish, could be something else. Could be no life at all. This is why we have to go and look. But if you can't get there with a spacecraft, and we don't have any of the Star Trek-y ones yet, unfortunately, then we have light that we can actually look at to figure out what is in the air of these planets. And one of the things I wanted to point out is that our sun, like every other star, is becoming brighter and bigger with time. And so in a couple of billion years, so don't worry, we have a couple of billion years, we'd better be a spacefaring nation, international nation, because this is how big our sun is going to get. This is how big it is now. This is how big it's going to be. And this is the orbit, the distance of Mercury, Venus, and Earth. So the good news is, in a couple of years, billions of years, so lots of time, a couple of billion years, you can touch the sun. The bad news is, it's probably a smidget hot while you do that. But we have one object that has left our solar system, Voyager 1. Voyager 1 is the only human-made object, human-touched object that ever left our own solar system. And before it did that, it actually had a look back and looked at the Earth. And this is what it saw. This is the Earth. This tiny pale blue dot that Carl Sagan wrote an amazing, beautiful, beautiful poem about. And this tiny dot still tells you a lot of information. So you have this tiny dot, and you really can see continents or oceans, but if you split the light in its colors, the light that gets to you gets filtered through the planet's atmosphere to you, then you can check if there's some energy missing. Because light is energy, you put your hand out and you see that it gets warm. So light, when it hits molecule in the air all around us, can actually hit them so they start to swing and rotate. And that light is unique, the one that's missing, to the molecule that it hit. And therefore, the light that does not get to my telescope tells you what the composition, the chemical composition of the air on another world is. And it looks a little bit like you had an apple and you took bites out of it. And this is how you can say which molecules are in the air of a world that are really, really far away. Of course, we also have planets that don't have life, like Venus, and they have their own light fingerprint. So we know how light fingerprint looks like. That's oxygen with a reducing gas like methane, and how other planets that don't have light look like. And so
the spectral fingerprint of life for our own planet is ozone with methane and water. And that's what we're trying to find on other worlds. And the last tiny point that I wanted to make, life, of course, doesn't have to be like you and me. Life can be very, very different. And then the planet would also appear very different if you think about a huge algae bloom, for example, that could cover the whole world. It could be red, or it could be yellow, it could be any color you really want. And life? This is a really interesting extremophile. It's called a water bear, and it basically survives anything. You can radiate it. You can even put it into space. They took it to space, opened the door, put it out without any protection. 3 days later, they put it back in, put a little bit of water on it, and was like, it was fine. So this is probably really where astronauts go in the future, something like this. Dehydrate them, put a little bit of water on them. I actually gave a talk to about 100 astronauts. They did not like that joke at all. You find these extreme forms of life here on our planet. For example, in Yellowstone, all these different colors are different forms of life. And so we're looking at that, and we're making a color catalog of life that's just not the flower you think of or the tree, but different forms of life that can live in very, very different conditions. And this is just a subsample of the color catalog of life we assembled. And one of them is a coral that biofluoresces. So why I want to bring that up is that in addition to these other Earths maybe not being pale blue dot, but red blue dots and green blue dots and any other color you can think of, we could actually also have really weird lives. And some of the last planets that were discovered are orbiting small red suns. One of them, our closest star. Even our closest neighboring star, our closest star is the Sun, 8 light minutes from us. The one after is 4 light years away from us, Proxima Centauri. So if you shrink our solar system to the size of a cookie, and I want everybody to think about cookies and astronomy together now, whenever you have a cookie, then the next star in the same scheme is 2 football fields away. And I was told not to use soccer here. Even so, the ladies' team is doing great. But the question is, this star, this red sun, is very different because it has flares, so it hits its planet with huge amounts of UVs. But actually, the coral I just showed you before, if you hit it with huge amounts of UV, what it does, it actually biofluoresces. So maybe, and this is a big maybe, on another world, this is work that one of my postdocs did in my lab, on another world, such a huge flare of UV radiation that might be really bad for life could actually lead to a sign of life for us to be able to detect it in the biofluorescent flare. And of course, just think about it, there's this other system we discovered, small star, 7 Earth-sized planets. The other planets in your night sky, if you were standing on that planet, would be as big as the full moon. And then just imagine you'd see 2 of them on each side of you, and they might actually flare in these beautiful biofluorescent colors. Does it exist? I don't know. But it's definitely something that we should look for with the next telescopes. And so our reach towards the star is one that we're just starting. And I sometimes like to think about it as like we making a travel list for the coolest destinations around our solar system and beyond. We're taking together what we have, and we're making like a Lonely Planet's top 10 list for travel bucket lists. We don't have the ships yet to get there, but one of the things we do have is the first information of our travel destination. And in 2019, we'll start the follow-up of Hubble. It's a 6.5 meter telescope, so it's about 4 times me in size. That will be in space, and for the first time, will be capable to collecting enough light to actually find signs of life on other worlds close by, if such life exists. And so I think we live in an incredible, exciting time. And we are the generation that can actually transition from, are we alone to the universe, to, ooh, we figured it out.